Hello, and welcome back to the course on Physics for Engineers. We are still on the last chapter on our course, which is all about optics. So, in the previous lesson, we have discussed about the law of reflection, which states that the angle of incidence is just equal to the angle of reflection. And we also have the law of refraction or Snell's law, which states that the index of refraction is inversely proportional to the angles of refraction. Now, in this lesson, we will introduce uh, the topic of geometric optics. So, geometric optics is the study of images and how they form, image formation. So, they uses basically geometries to study how light rays form or create images. So, light rays are the one creating images. So, an object is defined as anything from which light rays radiate. It can be a point object or it can be a real extended object with height, width, and volume. So in this example, this is a point object, and a point object radiates light in all possible directions, spherical waves. So light can also be the object. Light can be from the object. If the object is self-luminous, it emits its own light, or reflected by it from another source by virtue of diffuse reflection. An image, on the other hand, is formed by the outgoing rays, which when you say outgoing rays, it's either reflected or refracted rays from the object. So light comes from the object and then it's reflected or refracted to create images. An image point is the apparent source of outgoing rays. So for example, this is a plane mirror, and then if there's an object in front of the mirror, then it will be reflected, and all of the light rays that you will see will look like it is coming from this point. And this is what we call the image point, the apparent source of reflected or refracted or in general outgoing rays. So an image can be described uh, based on its nature and orientation. So an image can have a virtual nature when the outgoing rays diverge from the image point, such as in this example here. The outgoing rays are actually diverging, spreading around, spreading, but they look like it's coming from this point here. So in this case, we can also say that an image is a virtual image. Its nature is a virtual image if the image is in the opposite side of the outgoing rays. So the outgoing rays or the reflected rays in this case is in this side of the mirror, and then the image is on the other side of the mirror. So images produced by plane mirrors are actually virtual images. So the image that you see in a mirror, that's not a real image, but that's a virtual image. So a real image is formed when outgoing rays converge to the image point, or the image is in the same side as the outgoing, you say outgoing reflected or refracted rays. So, for example, the image produced by our eyes are real images. The image produced by a projection screen is a real image. So, virtual image and the real image are both properties of images concerned with its nature. So, uh, if you're asked with the nature of the image, you can say if it's real or virtual. Now, you can also describe an image in terms of its orientation. An image is erect if it has the same orientation as the object, and an image is inverted if it has the opposite orientation as the object. So, for example, if you have a mirror, in this case, this is a plane mirror, the object and the image is erect. The image is erect because it is in the same orientation as the object, even though the image is virtual, but it is erect. Now, We will discuss this later, in spherical mirrors, the image generated by the outgoing or reflected rays is a real image, but it is inverted. So this is actually the image formed in our eyes. The image formed in our eyes is actually a real and inverted image, and it's processed by our brains, and the brain is the one flipping it. But the image that's seen by our eyes is actually a real but inverted image. So these are some of the object and image quantities. The object distance is the distance from the object to the surface boundary. So if this is the surface or the boundary, then the distance from the object to the boundary is the object distance, and the distance from the image to the boundary is the image distance. We also have the object height, the height of the object, and the image height, the height of the image. So we also have defined the magnification. Magnification is just describes the size of the image relative to the object. So if the magnification is greater than 1, then the object is magnified. If the magnification is less than 1, then the object is demagnified, or it becomes smaller. So the magnification is actually related to the ratio of the object height and the image height, or the negative ratio of the image distance over the object distance. So in this section, we'll also be in geometric optics. We'll be more focused on discussing on spherical surfaces. So we'll be discussing about spherical mirrors and then spherical lenses, or spherical reflecting surfaces and spherical refracting surfaces. So if you have a spherical surface, it will have a center of curvature C, the center of the circle or the sphere, for which the surface, the boundary is a part of. Then we have the vertex, it's a point in the boundary or in the middle, center of the mirror surface. And the radius of curvature is just the distance from the center to the vertex. And we have the focal point, it's actually the point between C and V. And the focal length, for this is for mirrors, it's half the radius, distance from V to F. And then they have the optic axis where the center, the focal point, and the vertex are all located. So that one. Those are the basic points and lengths in a spherical surface. But this is primarily for a spherical mirror. We'll discuss about refractive surfaces in the next lessons. Now, this is the most important part in geometric optics, such as the most important part in DC circuits are the Kirchhoff's rules, and we also have these sine rules. So it's always the sine rules that is very central to a physics concept. So you need to follow the sine rules or the sine conventions, or else you cannot go on solve the problems. So for the distance, for the object, it's positive if the object is in the same side as the incoming or incident ray. Otherwise, it's negative. For the image, it's positive. It's in the same side as the outgoing rays, and negative if otherwise. So in that case, that's a real image if it's positive. If it's negative, it's a virtual image. For the height, if it's pointing towards the positive y-axis or pointing upward, it's positive. And if it's pointing downwards, then it is negative. For the magnification, if it is positive, then it's erect, meaning the object and the image are in the same orientation. It can be that they're both pointing upwards or they're both pointing downwards. If the magnification is negative, then it means the image is inverted. So if the object is pointing upward, the image is pointing downward, and vice versa. That is inverted. A negative magnification is inverted. So for the radius and the focal length, the radius or the focal length is positive if the center or the focal point is in the same side as the incoming or incident ray. Otherwise, it is negative. So those are the sine rules. So just pause the video and study those rules, because we will use those rules in the next lessons on geometric optics. So in the next lessons, we will be talking about image formations in mirrors. And then in the last topic on geometric optics, we will be talking about image formation in lenses. So I will see you again in the next lesson.